in this example, we're going to use the naive approach to forecast and recreate table 6.7 in section 6.2 of the book. So take a second and go ahead and set up your workbook like we have here. These equations off to the right are just for our reference when we calculate the mean forecast error, mean absolute error, mean squared error, and mean absolute percentage error. You do not have to necessarily enter those into your workbook. Now, using the naive approach, we need to simply take the time series value, or the demand in our last period, and that becomes the forecast for our next period. Forecast is denoted as y hat. So equals the forecast in week 2 equals the time series value of week 1. Now that's a relative cell reference, so we can go ahead and copy that equation on down. Our next task is to calculate the forecast error. Forecast error is simply our our time series value, our actual demand, minus our forecast, or our y hat. And again, relative cell references, so we can carry our formula on down. Next, we'll calculate the absolute value of the forecast error. Here we can use an Excel function, and we do equals ABS, parenthesis, select the value, end parenthesis, and we get the absolute value of our forecast error. Copy that on down. Now we want our squared forecast error, or E sub t squared. So again, equals our forecast error squared. Relative cell reference, so again, copy it down. Then we have our percentage error. So equals E sub t divided by y, or our forecast error divided by our time series value, our y. And this is a percentage. If it's not a percent, you can go up here and click Excel's percent style button and you'll probably have to add a few decimal points to make it look how you want. Copy that down. Finally, our last column is the absolute value of that percent error. So again, use the Excel function for absolute value and copy your formula down. So now we want to go ahead and take this information to calculate our errors. But before we can do that, we can see in our formulas, we need a lot of sums. We need a lot of totals. So we'll go ahead and calculate those. So equals the sum of everything here. Now you can see a few things popped up here. This became the absolute value of our total forecast error. However, that is not what we want. We want the sum of the absolute forecast errors. So we need to copy this sum formula over. And again, we want these to be the sum of our percentages. So we want percentages here. And there we go. Now we are ready to use this information and calculate our errors. I'm going to zoom out just a bit so that we can see it all. See if this is good enough. Okay, so our mean forecast error, we can see the equation for that is the sum of our forecast errors divided by n minus k. Well, we know that n is the number of periods we have. We have 12 periods here. K is the number of periods used to create the forecast. So in our example here, our k equals 1. So for the mean forecast error, MFE, equals the sum of our forecast errors divided by n minus k, or 12 minus 1. 0.45 repeating. So let's clean that up just a bit. Make sure you're on the cell that you want. And there we go. Now we have our mean absolute error, MAE. Again, that's the sum, but this time of the absolute value of the forecast error, again, divided by n minus k. So equals this sum divided by 12 minus 1. Don't need so many decimals. Here we go. Keep these consistent though. Then mean squared error. So now we're in the next column. We take the sum of the squared forecast errors divided by n minus k. Oh. We can see that is 16.273. And now our last error is our mean absolute percentage error. So we want the sum of the absolute value of percentage error, this 211, divided by, again, n minus k. And this is a percent, and we have 2 decimal places, so that's good. So now our final task is to calculate the forecast for week 13. Well, remember, we're using the naive approach, so the forecast for week 13 is simply going to be the time series value, the y value, the demand that we had in week 12, so 22. So week 13 forecast equals 22. So just to recap, in this example, we used the naive approach to calculate the forecast, and then the mean forecast error, the mean absolute error, the mean squared error, and the mean absolute percentage error.